This screencast is about the addition and subtraction of polynomials. But before we add and subtract, let's take a look and review some things that make up polynomials. First of all, look at the following expressions. 4x, 5y, negative 6ab, 7x squared, 9xy squared z cubed. All of those are called terms. When we have an algebraic expression with just one term, they're called monomials. That's what we've been working with so far. Today we're going to start looking at polynomials. Polynomials are just made up of more than one monomial. We have special names for each of the different polynomials. Of course, we already said one term is a monomial. If there's two terms, it's a binomial. If there's three terms, it's a trinomial. And after that, we just use the word polynomial. When you add two polynomials together, we want to combine like terms. Just as a reminder, like terms have the exact same variable and the exact same exponent. So even though 5x squared and negative 12x, even though that they both have x's, their exponents don't match, so they're not like terms. When we add these together, you can rewrite it in this form. I want to put together what's alike. First, the 5x squared and the 9x squared. Altogether, that's 14x squared. Next, we have the 7x and the negative 12x. These go together as negative 5x. Finally, we have the numbers negative 2 and 13. These go together as 11. At this point, I'm done. The polynomial answer is 14x squared plus a negative 5x plus 11. Even though these are x's, they're not like terms, so we can't combine them together. In this example, there are three polynomials to add together: a trinomial, another trinomial, and a binomial. Let me write them out in a more practical form. Negative 12x squared plus 2x minus 1 plus 2x cubed minus x plus 4 plus a negative 5x plus 6. Let's put together all the like terms. First of all, there's only one term with a 2x cubed, so it's going to be all by itself. We also only have one x squared term, a negative x squared. But there's several x's. I have 2 here, negative 1 of them there, and negative 5x's here. Let's put them together as 2 minus 1 minus 5, which is negative 4x's. Last, I have some numbers to put together. Negative 1, 4, and 6. Altogether, that adds up to 9. So the resulting polynomial is 2x cubed minus x squared minus 4x plus 9. We can also subtract polynomials in the same way. The only thing that you have to watch for is the order that you put them in. This key word here, from, means you're going to be taking this away from this polynomial. That means when you write it, the 5x squared polynomial has to come first. I used parentheses with all of the addition examples just to help myself organize the work. but in this case, parentheses are required. It helps remind you that this subtraction is actually going to be distributed to all of the terms in this second polynomial. For subtraction, I suggest rewriting the problem over again. This time with the subtraction symbol distributed to all three of these parts. I'll have a negative 2x squared, a negative 9x, and a positive 3. Combining like terms together, 5x squared and negative 2x squared is 3x squared. Negative 7x and negative 9x is negative 16x. Negative 1 and positive 3 is 2. Let's look at another example of subtraction. Here again is this word from, which means I'm taking this polynomial away from this one. Write the 2y squared first. I'm going to be distributing the subtraction symbol to each of the parts. So I'll have 2y squared plus 9 plus 8y squared plus y minus 5. Combining like terms together, this 2y squared and 8y squared will combine as 10y squared. I have only one term that's just a plain y, so I'll stick that in the middle. And finally, the numbers 9 and negative 5 to combine together as 4. 10y squared plus y plus 4. Let's look at some additional examples that have multiple polynomials combined together. Instead of using the words add and subtract, they just write out with symbols. We want to use the same strategy. Wherever you see subtraction, we'll need to distribute. Again, I suggest that you go ahead and rewrite the problem. 3x minus 4 plus 2x minus 5 minus 7x plus 1. Altogether, I have 3x's, 2x's, and negative 7x's. That totals negative 2x's. I have negative 4, negative 5, and positive 1. Altogether, that totals negative 8. Here's an even larger problem. And the only thing I'm really concerned about is this negative sign being distributed. I'll rewrite this one as well. Plus 2y squared minus 8y minus 6. Because there's so many terms in this one, I'm going to go ahead and keep track by circling or underlining some way so that I can know which ones are completed. I'll combine the y squareds first. I have negative 1 of them, 2 more, and then 4 more in addition to that. So altogether there are 5 of those. A positive 5y, a negative 8y, and a negative 2y. Altogether there are negative 5y. And finally, just numbers. The number negative 2, negative 6, and negative 5, they total negative 13. The last problem we're going to look at involves grouping symbols. The brackets you see in this problem are just another way of using parentheses. It's just to help keep you focused. The big thing is in algebra is we always want to go from the innermost parentheses outward. The innermost parentheses in this problem is the 3x minus 1. Nothing can be combined here, so I'm going to start moving outward. Now I have 2x plus 3x minus 1. I'll copy the problem down just as you see it. But inside these brackets, I'll do the simplification. In this case, I have 5x's minus 1. The brackets there act just like parentheses. So this is really a subtraction problem. This negative needs to be distributed to the 5x and to the minus 1. We'll have negative 5x plus 1. The only thing left to do is to combine these x's together. In total, I have negative 2 of them, for an answer of negative 2x plus 1.